Python programming chapter 6, defining function. And in fact, you probably have seen many functions so far. So function is one way to do abstraction. So if you go to like AP Computer Science Principle course, AP Computer Science Principle course, they have 7 main ideas, 7 big ideas. 7 big ideas, and abstraction is one of it, the big idea. Okay, they have 7 big ideas. You need to remember that 7 big ideas. Let me find it from internet for you for the 7 big ideas. And abstraction is number 2. It's one of the most important part in the big ideas. So here you can type 7 big ideas. So you type 7 big idea in AP Computer Science Principle. So you can see first one is creativity. Okay. Second is abstraction. So abstraction is ranked second. And then data, information, algorithm, programming, internet, and global impact. So let's talk about the creativity. Creativity part means like programming or computer science need creativity. You need to invent something new. Okay. So don't follow or always follow the solution that people give you. That part is understandable. Second one, the big idea is the abstraction. So now let's talk about what is abstraction and what abstraction actually brings us, and that is related to function. So first, actually we may have some data. Say we may have some data. We may have elementary school student. We may have a middle school student. We may have some high school student. We may have some college student. So all of these, we can call it student, right? All of these, we can call them student. And in the school, you may have teacher, right? You may have staff. You may have technician. And all of these, we can call them personals, right? And the student and personal are the people, or we call it person in the school. If one of them is actually a person. So lower level is more concrete. Upper level is more abstract. So abstract, actually, we attract something in common. We try to attract something in common. So a person, we deal with a person, and the person can be a personal, can be a teacher, and person can be a student and can be a middle school student, right? So something is common with the person, say age. Every person has an age, right? A student may have GPA, but personal doesn't have GPA. They are teacher, staff, and technician, but they may have salary. So salary feature is common to personal, to teacher, to staff, to technician. GPA is common to college student, high school student, middle school student, and elementary school student. And only age is a common feature for a person. So this tree actually is a abstraction tree. Higher level, more abstract, lower level, more common. And it's actually more specific, more specialized. And lower level, we call it concrete. Higher level, we call it abstract. Okay? So that's the idea of abstraction. And abstraction is try to draw the extract something from something that actually more concrete, more details. So higher level, more specific, more simple. Lower level, more complicated, more details. So that's about abstraction. So about function, function is one of the way we do abstraction. There are 2 types of abstraction in computer science. One is called program abstraction or control abstraction. And another type is called data abstraction. So the one I told you about person, about staff, about student, about teacher, it's data abstraction. So I'm analyzing the data and then abstract the common stuff together. And right here, function is actually a function is actually a control abstraction. Okay, it's actually a control abstraction. So it makes the program reusable, modularize the structure program development, reduce the program size, and then information abstraction, and make program more readable. Okay, make program more readable. So let's show how function and abstraction actually will help you. It has these 6 different features, and most important part is number 1, the reusable. So it makes sense to reuse. That's the most important. Second, modularize. Okay, and modularize makes things structured. Third is make program readable. Okay, it makes things readable. So let's actually look at these 3 features: reuse, readable, and structured, modularize. Okay, so now let's look at a demo program. So let me call this program as control. Okay, so here I can write some programs, say eval input, and then here say right, and then assign this to name, right, and then actually later I print my name, right, and I have age eval input. The eval you can actually use integer or float or string to convert it, and then enter your age. Okay, and then print age, right, and I can have say ages equals eval input, enter your ages. Okay, and then print ages. Okay, so far actually I have 3 stuff, right? Name, age, and ages, and these 3 are unrelated data, but somehow I'm repeating the same program structure again and again. I'm repeating this whole program structure again and again for 3 times, right? For 3 times. So actually it is okay to write this, but if I want to simplify it, if I want to actually make this more reusable and more readable, this actually, if I have, say, 27 different data fields, this probably is not a good way to do it. Okay, so that actually is what we can improve. So right here, actually, let's do this. If I actually do, I can do define get data, right? And here I say message, right? And then actually this one I will return my data, right? So here I'll say data equals this eval things. And here I do not put this enter your name, and instead I put my MSG message over there, right? And then later here I say print data, right? So this whole thing I can actually just delete. And say enter your name. Okay, by doing this, I have two-way together, sitting together, but let's try. So here, enter your name, say Eric. Oh, and no, pass it, let me see. It doesn't accept this, okay. It just take a string, so let me redo it, okay. Just type, you just type Eric. Let me see. Name Eric is not defined. Let me see. Let's don't eval. Don't do eval. Okay, so this one actually, let's don't do eval on this one. Okay, and then here, let me see. Let's try this one, okay. Okay, so here, let's say 19. Age is 1, age 3. Okay, so that's the way actually I can do. So here actually, I can actually get, I should have, now I probably need to have two sets, maybe one get string, and then let me copy the other one actually call, the other one I maybe need to have someone called get data. Okay, and then this one I need to have the eval stuff. Okay, that's fine. And then here, this one should be get data. Okay, this one actually should be get string. Okay, and this one can be get string. Okay, and after that, we can also have mass equals get data. Right, English get data. Right, chemistry get data. Okay, so now I write two functions, but I actually get 5 different data fields, right? Okay, so actually this show you how to actually have a function for abstraction. And the purpose of having function for abstraction is like you actually make the function reusable. So you get data or get string, as long as they are compatible. You know, if actually one need the eval and the other one doesn't need eval, you have to have a separate function. So the data can be with the function can be compatible. Okay. Other than that, actually, these two functions actually we can actually help it to just use the function to help it to be compatible. Is that okay so far? Is that okay so far? So this actually is like making things using the abstraction idea. So we have two functions and then that achieve abstraction. So that's one way we do it to make things reusable. Okay. Second idea is like making things modular. Okay. So modular means like to a person, he doesn't need to know what is inside the function. He just need to know, okay, I want to get a string. So I put my here something, and it will get a string for me. And I want to get data. So this one will get data for me. And I just need to put my message over there. I just need to put my message. Okay, and you will get the right data or string for me. And it will also be printed out. That's the only thing I need to know. So here, usually you may need to write some command like provide message and get data and get a text string and print it out. Okay, you may write something command for it, and so the user will know that these are the function they can get, and then it will help you to achieve the function. And the programmer just need to know that, okay, I can call this function, and then I don't need to care about the detailed stuff in the function. Okay, and the function you actually have, you will have something over here. Actually, that's called parameter. Okay, or sometimes we call it argument. So argument is something you pass into the function. Okay, and then there's a return value. Return actually is the data that you will get. It's just like you have a function, and the function actually equals x plus 1. So if I give f of 1, it actually will return 2. So the value you get from here, that is actually the return value. So for mathematical function, actually we can get here, if I write a mathematical function, it's also a function. So here, for example, I can write a function. Right? I can write a function. So I can write a quadratic. I don't know whether you know quadratic or not, but let's try this one, quadratic. So I can have the A, B, C, and X. Okay? I can have the A, B, C, and X. So here, let me say, I will return A times X squared plus B times X plus C. That's the value I'll get. Right? That's a quadratic function.
Yeah.
Are you okay with quadratic function?
Yeah.
Okay. So now actually I got this quadratic function, right? So what I can do is like, for example, if I want to print out some data from, say, from some data, this one, say, if I want to get y equals x squared, and then I from minus 1 to 1, okay? From minus 1 to 1, actually, each one, like 0.1 distance, I print the point. So here, totally from 1 to minus 1 and 0.1, how many points will be here? How many points will be here? From minus 1 to 1, each one spaced by 0.1, how many points will be there?
3.
0.1.
Oh, but
Okay. The way to find it actually is, okay, if someone asks you a question like from 1 to minus 1, what is the distance? What is the distance between the distance from minus 1 to 1?
2.
And it's easy. It's actually 1 minus 1. You get 2, right?
Yeah.
But this one is different. This one asks you how many points are there. Say if I am spaced by 1, so how many points I have? I actually have 3 points, right?
Yeah.
And how can I calculate it to get a 3? It's not like 1 minus 1. You should do here there is a point that is actually measured. So this one actually is, you are measuring the distance between 1 and -1, right? But this one actually, for you to count, if the spacing is 1, you are counting the number of the pole over here. Stick or pole over here. So basically, it's totally 3, right? But how can I know that it's actually 3 by calculation? So you should think about it as one guy that actually missing. So each one of them share by 1 spacing. Each one has a 1 spacing. So here is 1 spacing, 2 spacing, 3 spacing. So a point with spacing that's 1 count. A point with spacing that's 1 count. A point with spacing that's 1 count. So basically right here, you need to use 1 minus 2. This 1 minus 2 is the one that's not showing up. So totally you will end up with such a calculation, you will get 3. If you need to count the number of point over there, each one spaced by 1, you need to 1 minus the 1 that's not there. So that's totally 3 instead of 2. 2 is 1 minus 1. Okay, so this one, if we actually we come back to our original problem. We are from 1, 0, minus 1, each one spaced by 0.1, right? Spaced by 0.1. So I start from 1, and then there's a, let me do this. I start from 1, and then each one spaced by 0.1, right? 1 is included, right? But my 0.9 actually is not included, right? So there's the next one actually starting from 0.9 down to 0.8, and 0.8 is not included, right? So there's the one, last one actually is 1, and then this one actually is minus 1.1, and minus 1.1 is not included. So you are counting number of sections here, right? So what you need to do is 1 minus 1.1, right? Divided by the spacing is 0.1. So this one you got 2.1 divided by 0.1, you end up with 21 points. Is that okay? Is that okay? Okay, yeah. So that actually totally 21 points. So right here, what we need to do is like for I in range from 0 to 21. Okay, so from 0 to 21 actually totally 21 points. That actually is from 0 to 20, and 21 is not included. So later totally is 21 points. Is that okay? Is that okay?
Yeah.
And that actually I need to adjust to. That actually I need to adjust to the range of minus 1.1 to 1, right? So what I should do is like the 1 over here actually is 0.1. So I would have a base value of. So my base is actually minus 1.1, right? So here I should have my x value should be my base plus I times 0.1. Is that okay?
Yeah.
So I have a base of minus 1 point. I'm sorry, minus. I'm sorry. Here should be minus 1.0, not 1.1. Okay. So what happened is like right here, my base, the last one, the last one actually is minus 1, right? So this one actually I equals 0, right? And then this one, second point, actually I equals 1. So I equals 1, I get minus 0.9, right?
Yeah.
Okay, so actually that one is I equals 1, so 0.1 plus minus 1. So the last one, actually I have the 20, and then 20 times 0.1, I get 2, right? Plus minus 1.0, that's base. I get my x to be 1, right?
Yeah.
So actually this is 3 pin over there, and here I use the base to explain to you, but in fact right here I can just use the value minus 1.0 over here, and actually I'll remove this line. It's not necessary. Okay, I get my x will be formed by this, right? So I get my y equals this one. Actually is what? Quadratic of this time I'm trying to show you y equals s squared, right? So a equals 1, b equals 0, c equals 0. Okay, so right here actually I can actually put here is like 1, 0, 0, and then x, right? I put my s in there, and my a equals 1, b equals 0, c equals 0, I'll get my y, right? And after that, I will print all my points. So here I have f 4.2f comma percentage 4.2f comma. Each time I print a point, right? Percentage, I have x and y. Each sy I print out a point. Okay, each sy I print out a point. Okay, so each time I feed my x in there to over there. So with that, actually let me run it. Okay, so actually I got all my value from 1 to -1. Is that okay?
Yeah.
Okay, so here actually I have this one. And if I adjust, I can put my x in front. Okay, and then here I can put my x in front. Okay, so that actually is my function. So one more thing to talk about. This one actually will still work. Okay, still work. Now there's one more thing to say. Here, if I do this x here, right? A I say equals 0, equals 1. B I say equals 0. C I say equals 0. Okay, and if I here I just put a x. What does the a equals 0 do? It actually will give you the default value of 1 to A, default value of 0 to B, default value of 0 to C. So that's the default value. You can actually have the default value for the function. I'm sorry, I run the wrong program. So here, let me actually run this one mass function. Okay, it still get the same thing. Okay, you still get the same thing. If I can remove this over here. So if I only put a number, say 2, okay, and that 2 actually will be given to A. That 2 actually will be given to A. I'm sorry. That 2 actually will be given to A. So that 2 actually will be given to A, okay? And if I have 2 number, the second one will give to B. 3 number, it will give to C. So let's try. So right here, actually, if I have A equals 2, the value should double. Okay, the value double. And then if I give a 4 and 2, it will be given to B and C. Okay, anyway, so if you don't put equal over there, there will be no default value. And in that case, you need to specify every parameter or argument over there. But if you have some default value, you put 1, 0, 0, that variable you can assign or not assign. That actually is optional. And then if you have 3 that has default value, the first one actually will be A. The second one will be B. The third one will be C. Is that okay? Is that okay?
Yeah.
And also, if you actually have this default value and you actually don't know about the order, which one is A, which one is B, you can also equals B equals 3. You type B equals 3. So A will be 1 because you don't specify, you will get a default value of 1. C will be 0. Okay? Is that okay? Only
Yeah.
B will be 3.
Mm-hmm.
So you can actually, this one is called function with default value. Okay, this one is like called function with out of order. It's called function with out of order assignment. So you can just assign some value to some of the parameter and it can be out of order assignment. Okay, so your function can have a parameter list without default value. You can assign default value to it. You can also assign value by out of order assignment when you call it. Is that okay?
Yeah.
So now let's go back to our function. So that is about function and the readable, we know it. Okay, readable here, you have a quadratic function. So you just look at the function and you know what it is. Okay, the next one. This one is called call stack. Okay, call stack. Call stack is like we actually call a function, right? But right here, I have an x. And inside this function here, I have another x. This x and that x, two are actually different variable. Okay, these two actually are two different variable. Okay, this x is in the for loop, and that blue x is in the quadratic function. Two are of different functions. So how can I know which one is in power? So here actually, I don't have the x over here. Okay, so here if I say here I have this one t equals 0, right? And if I want to see this one t over here, okay, I cannot see it. I cannot see that t. So what I can do here is that I can say my t is actually global t. My t is actually global. If I declare it to be global, it will be the outside t. If I do not declare the global, actually this x is actually inside the local x. This inside local blue x is different from the white x over here. So let's run this one. Okay, and if I change to 10, here, let me see, if I change to 10. Yeah, no, let me have this one as t equals 0. So here actually, let me see. Here, before I call the function, after I call the function, I say t increase by 0.1, say. Okay, and see how it works. Okay, so actually t is increasing each time, starting from 0, increasing by 0.1 each time. You see that? So actually this t is this global t over here. Okay, that's called global variable. So this is the t is shared by every function and outside. But x is not. X without declaring as global. It's actually only local. It's a local variable, and this one actually is a parameter. And in order to make this happen in real programming, or in order to make this happen, we need to have something called call stack. And how call stack made this work? Let's see. So I originally have my main function. I have my main function, and then when my main function say I try to calculate my factorial, okay, I have my factorial function, and actually I would like to calculate my factorial. So let me write a factorial function. So I write a recursive factorial function. So here introduce the two ideal, something called factorial function and the recursive function. So let me call this function name as a factorial. So here I have a f function called factorial, and I have my n, right? And I'll return n times factorial of n minus 1. So if I have n equals 0, I will return 1. Okay, otherwise I'll return n times n minus 1 factorial. Okay, so here let me see, I try to print factorial of 5. I'm sorry, 4. Let's do 4. Okay, let's do 4 to be consistent with the example we have in the slides. So a function call itself, a function that actually call itself, this function it call itself is called recursive function. It's called recursive function. So right here, how this recursive function work is like, I originally want to call my function called this one 4 factorial. So my 4 factorial will be equals 3 times, I'm sorry, it will be 4 times 3 factorial, and 3 factorial will be 3 times 2 factorial, and 2 factorial equals 2 times 1 factorial, and 1 factorial equals 1 times 0 factorial, and 0 factorial is defined as 1. Okay, so here actually I'll get 0 factorial 1, 1 factorial would be 1, 2 factorial would be 2, 3 factorial would be 6, 4 factorial would be 24. Is that okay so far?
Yeah.
So here we had a same structure, okay? So here I say if n equals 0, this one actually tells you like 0 factorial equals 1, okay? And this one told you, this one called recursive formula. And it actually told you like n factorial equals n times n minus 1 factorial. Can you see the gray letters? Is that easy to see or no?
Yeah, I can see it.
Okay, so here actually you will see that that's something like this. Okay, so this one will define the factorial. So this one, if we run, okay, it will be 24. If I put 5, it should be 120 for 5 factorial. Okay, so let me put back to 4. Okay. It will be 24, and let's look at this one, the chart. Okay, so that's how we call this. We actually get the function working. So here actually, if I call my function, so originally I have the factorial of 4, right? So when I call for factorial of 4, originally I have my main function. So my main function actually is calling a factorial of 4. So my main function is under it. This is my main function. And actually I will call factorial of 4. And my factorial of 4 actually will call this one 4 times factorial of 3. And factorial of 3 we'll call 2 times factorial of 1. And 2 times factorial of 1 we'll call factorial of 1 equals 1, and something like that. And then you will return value back to there. So each one of them, we call it a call frame. And in the call frame, you will save your local variable and arguments and return address in order to keep track of which X it is. And if here has an X, that X is the local to the calling frame. So once the calling frame pop out, it will be dead. It will be dead. So what happened is that let's go back to our program. Let's go back to our program. Here, originally, I have my value 4 factorial, right? And I call 4 times 3 factorial, right? So first I have f of 4, and this one actually I'll call 4 times f of n minus 1, right? So when I is in f of 4, at that time my n actually is 4, right? And I call f of 3. So when I go into f of 3, at that time my n actually becomes 3, right? When I have the f of 3, I call 3 times f of 2, right? And I go into my f of 2, and my f of n of 2, at that time my n equals 2, right? So basically, whenever I call, starting from my main program, the lower part is my main program. My main program is to call f of 4, right? And I go into my f over 4. And in my f of 4, I have my n equals 4. And then I call my 4 times f of 3. So in my f of 3, my n equals 3. Then I go into f of 2, at that time n equals 2. And then I call f of 1, at that time n equals 1, right? And then later I go into f of 0, and in my f of 0, my n equals 0. Okay, so that n, I call it local variable. So in each call, this n is saved in something called stack. This one called stack. So once you finish the 0, you return, right? You return, actually that would be remove. So you get some value, say f of 0, you get in the f of 0, you get 1, right? So at that time when the n you are processing, this n actually is 1. So 1 times 1, you get what? You get 1. So this one actually remove. I'm sorry, remove up here. So that n equals 1 got removed. Oh, okay. So then this one become f of 1 as 1, right? This one you have f of 1 equals 1. But at that time, n equals 2. So you have 2 times f over 1. And you got 2. So you return 2. So when you, after that, you return 2. So you return 2. This one got removed. I'm sorry. I make a mistake again. Okay. And once you remove, you have the f of 2. And f of 2 at that time, it will be 2. So you have the f of 2 that equals 2, right? So you have f of 2 time, at that time, the n minus 1 is 2. Your n is actually 3. So you have the 3 times f of 2. So you will return 6. So then you actually finish that round. You remove this. So now you have f of 3. That actually is 6. At that time, your n equals 4. So you times 4. That you get 24. Right? So, and then you return. You get rid of this. And you return. and f04 no longer called by the f04. It actually called by main function. So right there, you return the 24 back to your main function and got printed. Is that okay?
Yeah.
Okay, that's how actually data being manipulated using the call stack. That's how data get manipulated by call stack. Okay, so function are called, and whenever you have a function call, actually the return address, local variable, and parameter are saved. Okay, 6.2 is function. 6.1 is what? 6.1 is graphic part. So 6.2 actually is function. So here actually it also have the different print for you. That's fine. And this part should be fine. Okay, I explain the main idea over here. Okay, 6.2 is okay, and return value actually I explained the return value already. So 6.3 should be fine. Let's see, parameter and function, I explained the parameter already. So that part should be also fine. Let me see. So we finished that 6.4. Let's try the next one. The next one is actually this one called function definition. Okay, so function definition basically you have put a name and formal parameter list and then your body. So here you have a function. This one is called name, and this one n is called parameter list, and the main body is over here. The main body is under it, but they should be aligned. Okay, it should be aligned, and then the alignment level actually defined is a code block. This whole thing is a code block. Okay, and f is the function name. F is called function name, and n is actually the parameter list. And I explained that if you have n equals something 5, that actually is called default value. So default value with some parameter with default value, you can skip it when you call it. You can skip it. You don't need to assign value to it. You will get the default value for you. So that part I explained it. Okay, let's try another page. So definition. The next one is case study future value graph 3. Okay. And then we have drawbar function. We try to group the drawbar together. Last time we don't have a drawbar because we use the X and Y. Each time we calculate different year and appreciation by itself. Okay, so this time we put each drawbar together as a function. Okay, let's look at that. Okay, let's look at that. So let's actually open that drawbar. So here, let's look at this future value 3. Okay, so future value graph 3 actually the original design I put it in comment. Okay, so basically you read in this print out this message, right, and then it asks for the principal value appreciation rate, right, the interest rate, and we actually draw a window graph, a graph window and then set background to Y, set a coordinate to this, right? And then we print out the text to the screen, right? And later we actually need to calculate the height, the bar, or something. This whole thing original in feature value 2, we actually need to calculate for each point. So we put them together into a function called drawbar, and we put it together over here. So we can actually recall it many times. Each iteration actually it will call it once. So that's the advantage of having this function for drawbar for abstraction. Okay, so now let's run it. So again, let's put the initial principal as this, rate as 0.1, right? Something like that. Okay, so this show you the advantage of. Let me see. You need to return input something. You need to enter into quick. Okay, I'm sorry. Let me actually change the program a little bit. I don't like this one. So here, instead of having this input, let me actually change to win.getMouse. Okay. Okay. So here, a group of the draw bar that you need to calculate each principal and use the principal and year to draw a rectangle bar. Those are also being put together into this function draw bar function. Okay, so you no longer need that. Each time you just need to put run the draw bar once. Okay, so that actually simplify the program a lot. And then the next one is to function with return value, just like mathematical function. So here it actually, you can declare something called square and sum and different. You can return more than one value. That I think I already showed these different functions. And then the next one is triangle 2. Remember the triangle, we can click for 3 points. So this one actually, it has the function of define square and calculate the distance. And actually, it will simplify the program. Okay, it will simplify the program. So let's run this one, triangle 2. Okay, you need to put 3 points and you will draw the perimeter. So right here, what's different is that you have a square function, distance function, and then you use the distance function to calculate for the perimeter. That's that. You actually click 3 points, and that 3 point actually, after you click, you return the x and y value for those 3 points, stored in the 0.1, 0.2, 0.3. And then actually you use that 3 point, you actually draw a polygon. And then after that, you calculate the distance between all of the 3 points, 0.1 to 0.2, 0.2 to 0.3, and 0.3 to 0.1. And then you calculate the perimeter and then print out the size of the perimeter into your message on the window. Okay, so that part is not hard. So that is the case study triangle 2. So we have this triangle 2, and the next one is call by value, call by reference. Okay, in Python, it actually is mostly called by value, but if it is an object, actually it is actually called by reference. Okay, what does that mean? Called by value and called by reference. So when you actually have some variable like integer or variable or something called you have something called integer. So what is actually called by value and called by reference? Let me show you something. So here, if I say Okay, something called by value. So here I have a function called f, right? And I put x over here, right? So here actually I put in x, right? And I say x equals 3, right? And then I put in my x again, right? And outside I have my x equals 4, right? And here I print x, right? After that I call f of x, okay? And this print I say x outside equals this, okay? And this print over here, I say x inside 1 equals this one. I call it x inside 2 equals this, okay? So now let me actually run it. This is called by value. So what happened is right here. So originally I have x equals 4. So I say print x outside. You print 4, right? And I copy the values 4 over to this blue x. So blue x equals 4. So I print x equals 4. So x inside 1 is 4. And then x inside 2, now x inside 2 actually is 3 because I modified x equals 3. So here, let me actually show you. If right here, actually, I copy this line again after I call the f of x, and I call this x outside 2. Okay, so f outside 2 will not be changed. It should be still be 4. This is called by value. Why? Because the x inside the blue one, this one update the blue one. It doesn't change the outside x. Is that okay?
Yeah.
But if I want to change the outside x, what should I do? If in my f of x, I want to change the outside x, what should I do? What should I do to change the outside x? If my f of x, I want to change my outside x, what should I do? Here I need to put global. Is that okay?
Yeah.
Okay, it doesn't allow global, but you need to remove this x and make it global. Argument, so this one actually I don't need to put it. Is that okay? So when I say it's global, actually it's the outside x. And when it change, the outside x got changed. Is that okay? So that's what it is. So here let me remove this. So this one call by value. Only the value is passed. Okay, only the value is passed. Okay, and what is called by reference? What is it called by reference? Okay, let me actually bring up the point class. Let me see if I have the point class. No, not here. Let me see if I have a point class. No, this one. Let me close this one. No, this one. Let me close this one. This one, let me close. Okay, here I have a point class. Okay. So here I have a point class over here. So this one, let me actually copy, okay, and paste right here. Okay, so here I have a point class, right? So I have a point class defined by myself. Okay, this one is actually defined by myself. So it's another point class in the other in the graphics. So here, if I want to use this point class in my own file, I should do from point import start. So now with this, actually I am able to access all the point defined over here. Okay. So in over here, actually I can actually do p1 equals 0.1, right? I can say p2 equals 0.45. I'm sorry, 0, 0. Okay, and then I actually have some function called, let me see, here I have a point. Okay, so some function right here. I can say define function set print point, and I say p. Okay, so right here I have my p, right? I have my p, so I actually can print my point p, right? And because here I already has the string function and reprint function, so actually it can print it using the print function. So actually here, let me call by reference. Wait. Oh, I'm sorry, I haven't called it yet. So I can print point and p1. I print the point 1. Okay, I have a 3 and 4, right? I have a 3 and 4. So right here in my point 1, if here I set some function, say I have a def, I have the set x, and then x, okay, and I say myself.x equals x, okay? And here I say define my set y, and I have my y value. I have myself.y equals y. Okay, I can have that define set get x, and this one will actually return self.x, and define get y. I will return self.y. Okay. Okay, I have this different function implemented. X and Y, just to get X and Y, just want to set the new value for the points X, or set a value for point Y. And also get X, get Y will try to get the value for point X and point Y. So here, let's go back to here, okay? I print my X and Y in here, right? I'm sorry. I set my X and Y in here. So I print out 3 and 4. I print out my point 1, right? I print out my point 1. And then here, if I say, set point, and I say print px, okay, and I say my px equals my eps dot set x by 6, my px dot set y by 8, okay, and here I say before change, okay. So I have my P1 and I have a set point, right? So here say I set point of my P1. After that, I print point again. Okay, so what happens is that I print my point P1 first, right? Actually, this one is not needed. This before is not needed. Let me comment it out. And then my point PX, my P1 passed to here, and actually I set my point PX, X and Y to be 6 and 7, 8, and I print outside over there. So this one here, actually, that's printed. Okay, that's wrong. Okay. So as you can see, P1's value got changed. P1's value got changed. If you pass a object, if you pass the object over there, you change the data for PS and PX. Actually, the data is updated. Compared to call by value, if right here, I just pass a value into there, X is changed inside, but outside X is not changed. But here, for the point, actually, I have the PX. I pass my reference value for P1 in there. My P1 actually set the X and Y, but my P1 outside got affected. This one is called call by reference. This one is called call by reference. So what is the call by reference now? Why the data got changed? So call by value is like I have the function, say, the one I have my f function, right? And then originally I have my x stored with 4, and inside here somehow I changed my x to 3, but the x changed to 3 is changing to the x over here. It actually changing the x over here. So my outside x is not affected. Okay, because when I call f of 4, I pass a 4 over there, but inside that's a separate x, and you update that x, that's fine. Your outside x not changed. That's called by value. What is called by reference? Call by reference is different. So here actually I create a point, and that point actually has 2 data fields, 3 and 4, right? And my P1 is only referencing to here. It's P1 actually store an address, say AB34, the 43 is actually the address for the data. Okay, so when I use this one called set point, my P1's data copy to my PX. So my PX store the value AB43. So my PX also pointing to here, right? And when it says set X and set Y, actually I'm setting here to 6, setting here to 8. And then after that, I print out my P1. When I print out my P1, I see the 6 and 8. So it got printed out over here. This one is called call by reference. Call by reference means the address is passed in. It's not actually passing the value. It's not like X, the previous X case. It actually passed a value into the function. Is that okay so far?
Yeah.
Okay, these two are very, 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 very important. Okay, you will see different language over and over again. So pass by value is like a copy of value for it. So it actually inside X is different from outside X. Okay, and for something that you create as a class and those kind of objects, it will actually only pass the address into your function, and actually because of that, your inside pointer may be pointing to the same object, and then you will actually change the data. So here we have two programs. One is called add interest. The other one is called add interest 2. Okay, let's look at this one, add interest 1. Add interest 1, I have a test. My amount is 1,000. So actually, I have this one amount 1,000 rate 0.5. So I pass right here. I pass my value 1,000 over here for balance rate. Actually, is 0.05, right? So my balance is 1,000. I times 1.05. I got my new balance, and I assign my new balance to my balance. Right? But this balance actually is what? Is my inside balance over here. It has nothing to do with this amount. It has nothing to do with the amount. So actually the amount still be 1,000. It won't change. How about on the right hand side? On the right hand side, actually, you pass 1,000 over here, 0.05 over here, right? It calculates for the new balance and you return the new balance. So it should be like 1,050 when you return. So it actually returns 1,050, and that actually assigned to amount. So when you print the amount, it actually should be 1050. And this is not called by reference, but it actually mimic by call by using mimic the call by reference. So if you assign a value to amount, actually it would change. But this one not assigning it, not actually has the return value. This one doesn't have the return value, so it has nothing to do with the outside amount value. It has nothing to do with this outside amount value. But here, this one actually, you get some return value from here, and it actually assigned to the value amount. So the value amount outside will be changed. Is that okay? So you can change the value by using call by reference, or you can use the return value to change the outside value. Is that okay?
Yeah.
Two ways you can do. And right here, you have the third way you can do is like, okay, I actually want to change my amount. I actually want to change my amount. Okay, so basically I put it a list. When it is a list, this one actually is a object. So it's only a reference. So I pass my amounts over and use the rate. And here actually I will update each individual one. So basically I have this one called amounts, right? And I have some value. And each time I update my value over here, okay? So this balances and the amounts, because both are reference, so my amounts is pointing to here. And my balance is also pointing to here. So actually, it's called by reference. In this case, it's called by reference because list is an object. So you update all the value over there. So when you print out the amount, it actually will be the new value instead of the old value. It's not called by value. This one actually is called by reference. So let's look at this three function. So let's look at these three functions. First one, add interest 1. Let me copy over.
周云婷，你不要忘记还有3分钟你要去接小孩哦。
没关系，我晚一点没关系，是留点 buffer 而已就可以。
我怕你。
Yeah, no problem, no problem. 我是不能拖太晚，我是怕说我万一要加时间是不能加的，所以先跟你讲一下。Okay, I have 8 interest 2. So let me copy my 8 interest 2 over as well. and then I add this one. This chapter almost done. Okay, don't worry. Interest rate. Okay, let's just run this 8 interest rate because 1 and 2 are simpler. So let's run this one 8 interest rate. So as you can see, the data actually updated for each individual one with the interest. Okay, interest one, you just pass the value in there, and it assigns the value to the balance, but the balance actually is a local variable. So it won't be changed. The outside amount won't be changed. It only changes to that local variable amount. So interest one, when you run it, the outside amount still be 1,000. The balance got changed, but that is actually virtually void. It actually not really doing anything. Okay, so we have about 4 or 5 different pages. Okay, let me actually continue. So that actually is when you actually look at the program. When I have a list, the list like amounts, it actually is a reference value. So it actually points into a list that has 4 entries of the data over there, right? Okay, and with that, each individual one, when you update, you actually update with new value. So when you print out the amounts, it actually comes with this different value. It's not like the code by reference. It's not like code by value. Code by value actually you don't update to each individual cells. Okay. So that actually is something you need to understand. So the next one is future value number 4. That's a graphic one. It's actually modularized. So it actually has the draw bar again. And then you put those main program into a main function. So this one actually is only to put things into a main function, nothing else. So that one is quite easy. Let me show you future value graph 4. Okay. I pass here. Okay, so the only difference is like originally my main function, I don't have main function. If you check the graph 3, actually, let me see. Okay, graph 3 already has a main function. Then what's the difference? Maybe these two actually are the same. Oh, it has a create labeled window function. It groups something into a group. So this one is a main function, but the window actually is not grouped together. So window function is outside. So future value number 4, it put the windows as a draw create labeled window. So this one you can actually reuse many times. So what happened is like here I create a window, right? Draw bar. So if I finish my window and then right here I say, again, let me create a window, right? Right here create a window, and here I call it window 2, right? And here I say window 2 that get mouse. Okay, I just want to show you why this window need to be grouped as a separate function so you actually can reuse it. Okay, so first let's do it. So you have the principle of $1,000, rate of 0.2, say. You draw this, right? So actually, if I get mouse, I click it, it will be done, and you create a new window. So this new window is created by this one. So actually, what happens like I group that whole group of the code, create a labeled window. So this one make the creation of the window reusable. So you can create multiple windows by using that create window. And in future value 3, you don't have that because you put everything into the main function, and main function you just run it once. If you want to do that again, you need to copy the whole code. After this, you need to copy that, and that actually is not module. So modularization actually also improve is another sense that one thing you actually do abstraction is for reusable. So we actually use the get data get string. So you just put your message in there, and then you can customize your get data or get string, right? That's one purpose. Actually make the code reusable. Another one is modularization. Once you have the modularization, my create label window can be reused several times, and it throw out the same window, but several times. Different window, you will create different window by create label window. That's the modularization part. So it's just like a car. You can, if your car is modularized, your engine break down somehow, and you can just take out the engine and put another new engine into there and still be working. That's a modularization. That's another advantage for having abstraction. Okay, so that part you can do. So here, let's do, you still do the true and false programming exercise 2, 4, 5. Is that okay?
Yeah.
So that's it for today. Is that okay? Any question, just let me know, okay?
Okay.
Okay, bye now.
Bye.
谢谢，然后谢谢，
Bye. Bye bye.
拜拜。
拜拜。